Hi, in this tutorial I'll show you how to perform a 3D track in a different way by using a survey solver. We have a footage with a table. It's quite simple, there's not too much movement. It should be easy to track. So we have 7 trackers, 4 for the top of the table and 3 trackers for the bottom. The table is actually almost a cube, so the width and the height are the same. The dimensions of the table and the focal length, it's in the bottom right corner of the footage. Okay, first we need to make some trackers to give some information to the PFTrack. We have a user track. I create a new one like this, connect it to the our footage. It's here, and we create a new tracker. Let's put it here. My first tracker centered. Okay, it's a good idea to name the trackers, so it will be easier to find them after, especially when we have much more trackers than 7. It's good to name the trackers concerning their placement. So I name it, for example, a table top, bottom left, like this. Also, we can make different colors, so it's easy to manage. Once you have our trackers configured, we click track, and there's tracking. As you see, it's quite good because there can be a little wiggling because when the track is stopped, it's okay. Just click again and repeat the step every time the track stops. There can be a little wiggling because there was not too much light in the place I took the footage, so the footage is a little noisy. It's not the point for this time, but keep in mind that you should a little denoise this footage. Okay, it's like this. I switch to the user track I already made. So we have the 7 trackers, 4 for the top of the table and 3 trackers for the legs. Once it's done, we need the camera solve. So I add the camera solver connected to the user track. It's like this. We need 2 constraints to help the PFTrack to orient the scene. Click Marquee and select the top trackers. Create, add to. So we added these 4 trackers as a planner to tell the PFTrack that these 4 trackers on different plane. We create another. Select these 3 trackers at the bottom. Add. And after this, we can click solve. It works. Change some rotation in the scene. So set the origin here and here. Scale it a little. Okay, as you can see, the track is quite good. It's actually fits. As I said, it can be a little wiggling, but it's not the point. But when we switch to the 3D view, like this, turn up the ground, it's a bit easier. The trackers that actually should be a square, for example, turn on the names and turn on the info. The trackers, they're set to the cyan. That should create a square. It's not a square, it's kind of strange, tetragon or something like this, but definitely it's not a square. It's a problem because when you switch to the 3D program, we want these trackers to be in the correct shape, in the correct relationship. Of course, we can fix it in the many different ways. But in this tutorial, I'll show you how to do this using a survey solver. So we have a survey solver node. We add it under our track user track. Okay, it's like this. There's no place maybe here. Connect this node to the user track. The interface is quite similar. We have okay. Let's get back to the video view. We have the trackers, and we have our seven trackers. And main difference is that we need the especially precisely defined coordination for each tracker. So there's a kind of coordination system with the, for example, X, Y, and Z axis. And we have to make some measurements on set while acquiring the footage. So for example, we choose the one tracker that will be our coordination system center, and its coordinates will be set to 0. Let's say it will be my first tracker I made. So tabletop down left. I select it, and for beginning, its coordinates are set to 0. It's the beginning of our coordination system. Sorry. The next tracker I want to configure it will be the tracker for the next right side of this our beginning. So it's here, the table down right. The width of the table is the 52 centimeters. The dimensions are set to meters, so you can change it, but let's say it's centimeters. I don't want to change it for now. And as I said, the width of the table is 52 centimeters. So we click it. Default it's set to 0, but we have to change this dimension to 52 because the X relationship between this and this tracker is the 52 centimeters. The rest is 0 because the Y and the Z is in the same plane, so of course it's the same. Okay, go to next tracker. It's a little harder. We add the Y dimension. Click it. The same. We said we have the 52 centimeters here, and keep in mind we set this value to the negative because we want to the y-axis to be positive upwards, and the height of the table is 44 centimeters. So we set this to minus 44. The z is the same because the z-axis is in the same plane here, so the z is the same. When we switch to the disk tracker, we have to change every dimension. So the x is 52, like this, and the y is minus 44, and z is 52, because the top of the table, the sides of the table are actually the same, it's square. And that's all. We have to repeat this step for every tracker. Okay, let's go back to the node I made already. Its dimensions. These strange numbers, it's little corrections that PFTrack made during the solving, during the solve. It's okay, leave it as it is. We click solve again to be sure, show ground. And as we can see, course, the track is quite good, except for the wiggling as you can see. So for now, it's no difference between the camera solver and the survey solver. Both made a good tracking, but when we switch to the 3D view, like this, let's zoom it out a little, turn up the ground so the trackers are more visible. When I select the stop trackers, you can see that the trackers create the trackers create a square. So actually the trackers are correctly placed. The table, the 4 trackers for the top of the table are correctly placed, and the 3 trackers for the bottom of the table are correctly placed. So it's easy to export, easy to work with the trackers. And actually that's all. The only disadvantage is that you have to make some measurement on the set, but in the next tutorial I'll show you how to find the dimensions, the length, and the relationship between 2 trackers or more trackers by finding some patterns found on the set. So it's not so hard to find some dimensions, because the clue is to find a relationship, not the dimensions. So for now it's all. If you have some questions, feel free to ask. I hope you understood this tutorial. Of course, you can add some orient scene when the tracking is you want to reorient the scene, but the rest of the workflow is actually the same as different ways. I think that this workflow is quite similar to other tracking softwares like Boujou or SynthEyes. This is example for the PFTrack 2011. Okay, so for now that's all. Thanks for watching, and bye.